Part 2 of the calibration video. This is the XTH-0-UNV, and it'll actually end up replacing the terminal strip in the thermocouple head. So it lines up to the same screws. So you just pull the screws out of the thermocouple barrier there, and then screw the hockey puck, I call it, in there. So here you have the red wire, which is always the negative on a thermocouple. The white wire is the positive, in this case on a J-type thermocouple. If you have a different type, then it'll be a yellow or different blue color. But white and red is J-type. And red, no matter what type, it has a red, and it's the negative. It's not the positive. So on the thermocouple or process connection point here, I have the red connected to the negative, the white connected to the positive. It's got 4 wires because it can handle a 4-wire RTD, but in the case of a thermocouple, you're just going to hook up the 2 wires to plus and minus. And the terminals are numbered, and there's a little wiring diagram that comes in the box with the unit. So you have to pick out what your process is, and in our case, you can see all these different options: RTD, 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 and thermocouple. And it doesn't really care if it's a JKT type. It's still the plus is plus and the minus is minus. Okay, so, and that's what we have. And then your 4 to 20 for your conditioned signal. Terminals 1 and 2, so you go plus and minus. They show a battery or power source in a load on here. So what I've done, I have a power supply, one of these type plug-in power supplies, with plus and minus on it. And the plus is the wire going to the plus, you can see on the transmitter. And just trust me, that goes to the power supply plus. So the power supply plus goes to the plus on the transmitter. The minus on the transmitter is what would be the signal. So this red wire goes to the input on my millimeter, if you will. So it's a signal processor, but we're just going to read the milliamps on the input. And so that's that side, and of course the other terminal on in this case the millimeter, goes to the negative on the power supply. Okay, so power supply plus to plus on the transmitter, minus on the transmitter. Well, I'm saying it backwards. Power supply plus goes to the plus on the transmitter, minus on the transmitter goes to the plus on the millimeter. The negative on the millimeter goes back to the negative on the power supply. In the case of reality, the millimeter will be replaced by a PLC. So the minus is the signal output on the transmitter, will go to the plus input on the PLC. The negative on the PLC analog input will go to the power supply in the control panel. So we're just reading what the PLC would see right now. And since I have this thermocouple connected, we're reading it. In this case, this is the current coming in, which is 5.51 milliamps. And I have it scaled, just trust me, 0 to 800 inside of this meter. So this is going to be what the process signal or engineering units are in Fahrenheit. So in this case, it's 72, 74, 75, 76, something like that, jumping around a little bit. If I were to put my hand on it, it would increase. If I got to reach the tip of the thermocouple there, and the value will increase. You can see it going up a little bit there, 76, 77, 78. Okay, I let go. So basically, that's that part. Now, the way we calibrate it on the computer is, okay, we set up a cable. It's a special USB cable. I think it's called a XTH-USB. Because XTH is a series. Okay, so that plugs into the USB port. The other end has a special connector that plugs into the transmitter. That's right here. So you need to have this special cable to program it with. So that's plugged in. If we come back to the computer, because this, remember, we read the unit. I'm going to change the calibration to 1000. So now this unit is calibrated, well, not yet, but it's 0 to 1000. You just have to be sure you match your thermocouple type. KLN, RSTU, so on and so forth. These are RTDs. So we did. We have a type J thermocouple. And you'll see it when I select that, it'll pop up the range of that thermocouple, which is minus 328 to 2192 F. We want it to be 0 or 4 milliamps at 0 degrees F, and we want it to be 20 milliamps at 800, but this example I'm showing you 1000. You can just as easily make it 500 or 300. A lot of times they'll go 32 to your high value, so that you know, it's 0C, if you will. But anyway, we're going 0F to 1000F, and we're going to transmit that here. It says transmit setup to unit. We're going to do that. It'll tell you if you don't have a connection. In this case, we do, because it's transmitting to the unit. And it's done. Now, what I usually do, I just read it, just to make sure I got it. So I'll come up here and read from unit. It better say the same thing. It used to say 800, right? Now, if we did it, it should say 1000. Okay, which it, well, there it goes. It's 1000. Now, we should have less milliamps over here now. We do. We had like 551. Now we have 52. And we could calculate that out, or in this case, I'm just going to change the range on this unit to 0 to 1000, which is what we have now. And I'm going to do that offline. That takes too darn long.